Dear student, we see today about an important topic, that is resonance. In last lecture, we discussed about what is a inductive effect. After learning the inductive effect, we are moving to the resonance, and in here I told that a resonance is a ruling part. Means जो भी फैक्टर है हमारे पास टू स्टेबिलाईज द इंटरमीडिएट अमोंग द ऑल, सबसे बेहतरीन और फर्स्ट टू सी फैक्टर इज अ resonance. What we have important in that case? So I can say this two letter is very important for us. Other than that, I can say this two letter is also important for us. So when a word resonance come in our mind, there should be that there is a moving of, one is charge and another one is electron. Moving of charge and electron. Na, not atom. So my intention here is to explain you, मैं ये बताना चाहता हूं कि जब रेजोनेंस आए then we should have a charge and electron delocalizations, not an atom. Okay, चलिए तो देखते हैं आगे. So here these are these basic explanations is here. I write some structure. So first I identified these hybridizations of all the structure. So if I find the hybridizations for the carbon, this is sp3, sp2, this is also sp2, this is also sp2. If you have not seen a video of hybridization, then see that, then you get idea regarding that case. This is sp3, this is sp2, sp2, sp3 and sp3. Later we see about second structure, sp2, this is also sp2, sp2, sp3, sp2, this is also sp2, sp3, sp2 and sp3. What about this? I can write here sp3, sp2, 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 sp3. What about this? sp3, sp2, sp3, sp2, sp2 and sp3. By observing a such structure, I want to explain you is, here if you see that there is a consecutive 3sp3 structure or carbon, there is also 3 consecutive sp2 structure, there is also 3 consecutive sp2 structure. Here only 2 sp2 structure, here also only 2 sp2, here 3, but it is not a consecutive. Here also 3 sp2, but that also not in consecutive mode. So I can say that यहां से हम वो conclusion पे आ जाएंगे कि this structure show resonance, this structure show resonance, this structure show resonance, the structure does not shows the resonance. So the final conclusion is, in our structure, if we have 3 or more than 3 consecutive sp2 structure, we can say that the chances would be there a resonance. 3 और 3 से ज्यादा consecutive sp2 hybridations होंगे तो ही resonance होगा. So let us see what is that. So electronic displacement in covalent bond, not possible in that case also, but I can say there are possibility of this one, electronic displacement, polarizations, a permanent effect, temporary effect. Among these are the main effect. So here inductive effect we have seen. I can say simply, if you have a sp3 carbon, then the effect is inductive effect. If you have sp2 then you can say it is it have a resonance effect. sp2 and sp3, then you can say chances of hyperconjugations. Inductometric and electrometric we will see later on. So among this all, today my topic is to explain you only a resonance effect, not any another effect. So let us go. I will not explain you anything, what is a resonance energy, why resonance come. I will give you the example and try to minimize your mistake to draw the resonating structure. So here the rules for drawing the resonance contributors. तो यहाँ पे हम जो रेजोनेंस स्ट्रक्चर ड्रॉ करेंगे वो सभी रेजोनेंस स्ट्रक्चर को रेजोनेंस कंट्रीब्यूटर बोलते हैं. Let us see. Only electron moves. Nuclei of the atom never move. I told you that only electrons move. So now the question arises, electron move. There are two types of electron. One is pi electron and another one is a sigma electron. Then we have to think which electron. So I can say the only electron that can move are, the first is pi electron, then second one is lone pair, third one is negative charge and unpaired electron. So I can say a pi electron, then lone pair, then negative charge, then unpaired electron. Mostly these all are known as a pi electron. These all are known as what? Pi electron. Let us see. The total number of electron in the molecule does not change, neither do the number of paired or unpaired electron. तो ये बोलना चाहता है कि इसमें हमारे पैड और अनपैड इलेक्ट्रॉन की संख्या सेम रहेगी, number same रहेंगे. Then let us see this with example, because this example will give a clear idea. Let us see one example. First I write in this way, CH2 double bond CH, then CH plus and CH3. If you see, there is sp2 and sp2, so resonance would be there. So if I draw the structure, here I will not show the arrow, later on I will show you how to draw this arrow also. So here if I draw the structure, then I could get CH2 plus CH double bond CH CH3. Let us keep the arrow also. And another structure, some student can like this, or they write like this, CH2 double bond CH CH2 and CH2 plus. Now if we see here, यहाँ पे हम देखेंगे तो देखना ये है कि it is CH3. If you see here, this is CH3. Here 3 hydrogen. Here also 3 hydrogen. No problem. Here one hydrogen, one hydrogen, one hydrogen, one hydrogen, and CH2 2 hydrogen. There is not an issue. So structure A and structure B are resonating structure because the atom are their place. Nothing do the change. But in case of structure A and structure C, if you see here, this is a 3 hydrogen and here this is a 2 hydrogen. So I can say it is structure A and structure C are not resonant structure because according to this rule, they do not follow it. Okay. So क्या बताना चाहते हैं हम यहाँ पे? We have to move a charge and electron, not a atom. Let us see another example. Suppose I have a structure like this, and I am drawing the resonating structure for this compound. then what I can get here? So I can get, I will not change the place of atom like this. So here written that you have to find the paired and unpaired electron. But dear student, a total number of electron to calculate, that will make us some mistakes. So what I will do, I will calculate number of paired electrons. What should calculate in paired electron? Then I can calculate a pi electron, lone pair and negative charge. These all are known as a paired electron. Let us see how many paired electron in this case. So there is a one pi bond, there is one lone pair, there is no charge. So I can say the total paired of electron is 2. Let us see here how many pi bonds are here. 1. How many lone pair? 0. How many negative charge? 1. So total paired electron is 2. If paired electron is matching, then always unpaired electron will match. Again, to calculate a pair electron or to match the pair electron, हमको unpaired electron मिल ही जाएंगे. Among the paired electron, there are two types of electron. One is sigma and one is pi. We will not consider in the sigma. If we calculate the pi electron, by default, sigma electron always match here. So this is a story to show you how to draw the resonating structure and all about. Let us go ahead and see which of the following resonance structure of each other. Here shows that the first we consider about the structure of this one. So is this two structure are a resonating structure? Then first what we have to find? First we have to see whether the atoms are changed or not. Yes, dear student, if you see here, यहाँ पे देखेंगे तो यहाँ पे ऑक्सीजन ही है और यहाँ पे हाइड्रोजन है. So वो क्या बताता है? वो दिखलाता है कि the hydrogen atom changed the position. So I can say it is not a resonating structure. Here also, if I show you among these two structure, the position of oxygen is changed here. Here oxygen is attached to nitrogen only, but in the case of this structure, oxygen attached to the nitrogen as well as carbon. It means the change of atom, not atom change. Resonance में हमें atom को change करना ही नहीं है. So there is a change in atom. So these are also not a resonating structure. Let us come at here. The position of nitrogen is in center and here the position of the nitrogen is on terminal part. So I can say that the position of nitrogen is changed. So this is also not a resonating structure, right? This is also not a resonating structure. Let us go ahead. So whether the structure is correct or not, to check it, what we should have to check, हमें क्या check करना होता है? So in that case, we check the position of atom. If the position of atom is same, then I can say the almost chances of resonating structure. Let us go ahead. The electron can be moved in one of the following ways. How can electron moves? Electron कैसे move करते हैं? कई बार arrow यहाँ से वहाँ जाता है. कोई बार arrow from this direction to this direction moves. So let us see here how it is. There are, according to me, there are two types of resonance. One is 3-atom resonance and another one is 2-atom resonance. First we see about 3-atom resonance. Let us see, move the pi electron. We have to move a what? Pi electron. देखो ये pi electron मैंने draw कर दिया. Now move to where? Pi electron moves toward a positive charge. Yes, moves toward the positive charge. Moves toward the pi bond. Yes, moves toward the pi bond. Moves toward the lone pair. Toward a pi bond. Moves negative charge toward the pi bond. Then moves a single non-bonding electron toward the pi bond. ओके, सो नाउ व्हाट इज रेजोनेंस? तो हमें ऐसे ट्रेन शुरू करनी है, यहाँ पे एक ट्रिपल बॉन्ड भी रख देंगे. सो व्हाट इज द ट्रेन? ट्रेन इज डबल सिंगल प्लस डबल सिंगल डबल डबल सिंगल ट्रिपल डबल सिंगल लॉन पेयर डबल सिंगल माइनस डबल सिंगल डॉट. ये सब रेजोनेंस है. फिर से डबल सिंगल प्लस डबल सिंगल डबल डबल सिंगल ट्रिपल डबल सिंगल लॉन पेयर डबल सिंगल नेगेटिव चार्ज डबल सिंगल डॉट. सो कैसे दिखाए जाएंगे यहाँ पे? तो ओ दिस इज अ रेजोनेंस. यस, इट हैज रेजोनेंस. यस, इट हैज रेजोनेंस. यस, इट हैज रेजोनेंस. Yes, it has resonance. Yes, it has resonance. Yes. तो ये सब इस टाइप के जो भी स्पीसीज होंगे इस सब में रेजोनेंस होगा. So the question is where to move and how to move, that I will show you. Let us see this two atom resonance. ये बहुत ही बेहतरीन रेजोनेंस है. Dissimilar charge near by atom. So I can write here, if I have one atom is A and another atom is B. So on atom A, I have a lone pair or negative charge and atom B has a positive charge. Then this is also resonance, dear student. How? I will show you the exact example. I have OH and CH2 plus. It is matching with this one. And it is matching with this one. So I can say this is also a resonating species. So whenever the story of resonating structure come, you should have to remember this one and you should have to remember this one. So ultimately I can say other than sigma bond, all the remaining electron can move in the resonance. Let us go ahead. Confirm a resonance structure is correct or incorrect. So here, after drawing the resonating structure, we have to confirm whether I have drawn the resonance structure is correct or incorrect. To check it, I have shown you a 4 possibility. Suppose I have this is structure. Suppose I have this is structure. Suppose I have this is a structure, and suppose I have this is structure. So this is my parent structure. When I draw the structure, then I must have to know that. So what happened here? A negative charge, lone pair और pi bond. यहाँ से ही arrow start होगा. The first preference is given to a negative charge, then lone pair and double bond. Then how to draw here? Suppose this is 3 atom resonance. So I can say between these 3, all are sp2 hybridizations. If you want to check, you can check it. So the electron will give it here and that come at here. So I write here A, B and C. So I told you that whatever in AB that come in BC and whatever the charge on C that come on A. Again, whatever between A and B moves to B and C, and whatever the charge on C come to the A. So now I draw the structure. It could be like this. One more possibility is I can draw here like this. So again I will write here A, B, C. So you can clarify it. So this is A, B and C. जो A और B के दो बीच में है वो कहाँ पे आ जाएगा? B और C. और जो C के पास है वो कहाँ पे आ जाएगा? A के पास. Now here the arrow is inverse because the arrow will start from the negative charge, lone pair or pi bond. So here this electron moves in this directions. So I can say this is A, B and C. A और B के बीच में जो होगा वो कहाँ पे आ जाएगा? B and C, or whatever the charge on C comes to the A. So you have to draw like this. You have to practice like this. Later on you will understand how to draw this. Here also A, B and C. Whatever on C come to the A, and whatever between A and B that come to the B and C. Let us try to draw it. Yes. Now what about this one? So come, we will try for this also. So here pi to pi, for wherever you want you can do it. Double bond A, B and C. So what happened? Here you have to do like this because there is no charge, so a continuous sequence will arise. So from this A produce a positive charge because electron move from that and it reach to the D, so a negative charge will come at here. So there is one electron. This arrow shows a complete arrow shows a pair of electron. Now I write here a half arrow. What half arrow indicate? Half arrow will indicate just one electron. So I can write here like this. It is also same A, B and C. A और B के बीच में जो है वो कहाँ पे आ जाएगा? B and C, whatever on the C come to the A. So what happened? Okay, again I move this one electron from here, one is here and another one is here. So what happened? A, B and C. A और B के बीच में जो है वो कहाँ पे आ जाएगा? B और C, और C के पास जो है वो यहाँ पे आ जाएगा, right? So here the what is importance it here is, I want to show is the main structure has a net negative charge, all other must have also a negative charge. ये दिखलाना चाहता है कि यहाँ पे नेगेटिव चार्ज है तो इसके जितने भी रेजोनेटिंग स्ट्रक्चर होंगे इसमें नेगेटिव चार्ज ही होगा. अगर पॉजिटिव हो जाता है तो बता देना कि हमारा बनाया हुआ स्ट्रक्चर गलत है. If it is positive charge here, then all the structure has positive charge. A main structure containing a positive charge, all structure containing a positive charge. अगर इसमें नेगेटिव आ गया और इम्बैलेंस हो गया तो वो दिखलाता है कि हमारे स्ट्रक्चर गलत है. Now here net charge is 0. See, it is written net charge. So net charge is 0. If the net charge is 0, then in all the structure a net charge is 0. So this is -1, this is +1. So among these two I can say total charge is 0. In that case, in this way you have to think here. Here one unpaired electron, तो यहाँ पे one unpaired electrons है तो सभी ही स्ट्रक्चर में क्या होगा भाई? unpaired electron ही होगा. This is unpaired electron, this is unpaired electron, एक यहाँ पे भी unpaired electron होगा. I forgot to write it, but I will keep it here. Okay, so this is also one of the unpaired electron of our structure. तो ये यहाँ से पता चल जाएगा कि भाई हमारे स्ट्रक्चर करेक्ट है कि नहीं है. Okay, the preference you have to give according to negative charge, lone pair and pi bond. In this way only you have to move the structure. अगर नेगेटिव चार्ज और लॉन पेयर दोनों है तो नेगेटिव चार्ज को प्रेफरेंस देना है, लॉन पेयर और पाई बॉन्ड दोनों है तो लॉन पेयर को प्रेफरेंस देना है. सही बात. चलते हैं आगे. लेट अस मूव अहेड. So what is M plus effect and what is M minus effect? If you have seen my video, then I told you that there is I plus effect and I minus effect. So normally ये प्लस है, ये माइनस है. A minus will विदड्रॉ द इलेक्ट्रॉन, वो खींचेगा, एंड प्लस उसके पर चारों हाथ हो गए उसके, बिकॉज this is one hand, two hand, three hand and four hand. It will gives the electron. In any structure, I can say there is one M plus group and there is one M minus group, always is there. So here it gives the electron, then it take the electron. So I can say this is M minus and this is M plus. I am agreed. But dear student, whenever anyone asks you what is the effect, इसमें कौन सी इफेक्ट होगी, M प्लस की M माइनस, तो आपका आंसर होगा M प्लस. क्यों? क्योंकि ये इफेक्ट फंक्शनल ग्रुप की है, और जब बात फंक्शनल ग्रुप ऑर्गेनिक केमिस्ट्री की आती है ना, तब वहां पे फंक्शनल ग्रुप ही आती. So always in any structure both the effect are that, but we have to think which effect, effect of a functional group. Let us see what is M plus. I have told you what is I plus effect. If you have seen my video, if you have not seen, then please see that, then continue with this video. So here for M plus I give you a one logic, you write it. Single bond atom with lone pair, this is known as a M plus effect. I plus में मैंने बताया था कि सिंगल बॉन्ड कार्बन एटम, यहां पे मैं बताता हूं कि सिंगल बॉन्ड लॉन पेयर कंटेनिंग एटम इन कॉन्जुगेशंस, single bond lone pair containing group. So here also we make the case number 1. केस नंबर 1 में M प्लस में कौन आएंगे, जो माइनस हो गए. So this is always first. So if we say a lone pair containing element, then carbon, nitrogen, oxygen and fluorine. So among these, carbon have no lone pair, so it will not come in this the picture. Then we have to think about what about this. Nitrogen has one lone pair, oxygen has two lone pair, fluorine has three lone pair. Which will come the first? So dear student, I can say that M plus effect is inversely proportional to the electronegativity. जो इलेक्ट्रोनेगेटिव ज्यादा होगा, जो जल्दी से इलेक्ट्रॉन नहीं देगा, जो इलेक्ट्रॉन ज्यादा इलेक्ट्रोनेगेटिव होगा वो जल्दी से इलेक्ट्रॉन नहीं देगा. सो फर्स्ट ये कम इलेक्ट्रोनेगेटिव है नाइट्रोजन, तो उसकी इफेक्ट जल्दी से आएगी. सो केस 1 इज गिवन टू द प्रेफरेंस 1 एंड केस नंबर 2 वी सी लेटर ऑन. उसके बाद क्या आएगा, केस नंबर 2. तो इसमें कौन आएगा, सिंगल बॉन्ड कंटेनिंग एटम विथ लोन पेयर. यस, उसके बाद single bond containing atom with a lone pair, single bond containing atom with a lone pair. After completion of the nitrogen we have single bond containing a lone pair, single bond containing a lone pair. Then after completion of that I can say उसकी इफेक्ट कम होगी, क्योंकि उसके पास में लॉन पेयर के पास ये रेजोनेंस आ जाता है. देखो डबल सिंगल लॉन पेयर, तो ये थोड़ी उसकी और अट्रैक्टेड होगी, राइट. देन दैट वन. उसके बाद OCOR, दिस इज वेरी इंपॉर्टेंट. ये एक ही खिलाड़ी ऐसा है कि जिसके पास lone pair nahi hai, but they have a pi electron. So after that we have a fluorine, chlorine, bromine, argon, iodide means. Then we have NO. Now I hope you have two confusion. The confusion number 1 is, आपको ऐसा लगता होगा कि सर यहाँ पे तो 2 पेयर ऑफ इलेक्ट्रॉन है. इन केस ऑफ ऑक्सीजन वी हैव 2 पेयर ऑफ इलेक्ट्रॉन, तो वो ऑक्सीजन नाइट्रोजन से पहले आना चाहिए, क्योंकि उसके पास 2 पेयर है. बट डियर स्टूडेंट, इफ यू सी हियर, whatever the pair of electron with oxygen, only one lone pair will move in a resonance. Whatever the pair of electron with oxygen, only one pair of electron will move to the resonance. उसका रीजन क्या है वो मैं आपको बताता हूं अभी. First we will see this M minus effect. So what is M minus effect? उसके अलावा देखो सिंगल बॉन्डेड लॉन पेयर नहीं होंगे, that all are what? M minus effect. So what is the first? N I minus में जो था फर्स्ट वही होगा. देखो ये डबल बॉन्ड आ गया, लॉन पेयर होगा तो भी वो नहीं कर पाएगा क्योंकि O माइनस और पाई बॉन्ड विल विथड्रॉ दिस इलेक्ट्रॉन. Then NO, then we have aldehyde, ketone, then we have ester, then ester, then we have last there is carboxylic acids, right? So this is the sequence. This all are M minus effect. वो सभी डबल बॉन्ड वाले ही होंगे. देखो ये डबल बॉन्ड, this is also pi bond, 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 right? So what is M plus? M plus means single bonded atom with a lone pair of electron. अभी मैंने आपको बताया कि भाई ये 2 हो गए तो एक ही पेयर रेजोनेंस में क्यों चली जाएगी. So here we see that I have a structure. Suppose I have a structure like this one. So now if you check the hybridizations of oxygen, then you come to the conclusion that there is a sp2 hybridizations. So how many pair of sp2 hybridizations? There are total 3 sp3 hybridizations. 3 sp2 hybridizations. So dear student, मेरा कहना यह है कि ये 2 sp2 में 3 sp2 में क्या होगा? The 2 sp2 bond sp2 form a sigma bond. Form a sigma bond. And one sp2 contain lone pair. तो यहां पे 2, यहां पे 1, ये 3 हो गई और एक p ऑर्बिटल remaining vacant, and that p orbital containing a lone pair of electron. So my intention here is very clear. One pair is in sp2 and one lone pair is in p orbital. So dear student, in case of resonance, always a p orbital will involve, not sp2 orbital is involved, and it required a planarity in a same plane. It required in a same plane. So जो इलेक्ट्रॉन p ऑर्बिटल में होंगे वही रेजोनेंस में भाग लेंगे. So let us go ahead. So ये तरीका हो गया. Now let us go ahead, draw the resonance structure of this case. So we try to draw the resonating structure. तो यहाँ पे हमको रेजोनेटिंग स्ट्रक्चर ड्रॉ करना है. तो कैसे करेंगे? देखो यहाँ पे लॉन पेयर भी है. उसके 2 तरीके हो सकते हैं. इफ यू थिंक अबाउट दिस फंक्शनल ग्रुप, तो आपको दिखेगा कि ये कौन सा ग्रुप है? M माइनस. M माइनस क्या करेगा? डोरी की तरह खींचेगा. सो व्हाट इट विल डू? दिस इलेक्ट्रॉन कम एट हियर and this pi electron will come at here. So what you get here, don't change the place of atom. And second thing, we have to check, इसमें नेगेटिव चार्ज है तो सभी में नेगेटिव चार्ज होना चाहिए, इसमें भी है. So this is our resonating structure. ये एरो इस तरह होगा. Arrow, to draw this arrow we have two possibilities or two thinking. One is to check the functional group. Another one is you can see the, I have told you this arrow will start from the negative charge, lone pair and pi electrons. Here this is two atom resonance, student. So always a single bonded lone pair group, so this is M plus. तो ये तो देगा देगा तो किसको, सिस्टम में. व्हाट इज दिस, M माइनस, ये खींचेगा किसकी तरह, उसकी तरह. CH2 डबल बॉन्ड O प्लस. Here also it involve a one lone pair only because एक पेयर किस में होगी, sp2 में, और दूसरी पेयर कहां पे होगी, p ऑर्बिटल में. Now this is also M plus. It will move in this directions. Then it comes at here. Because arrow will start, preference is given to the lone pair rather than pi electron. So I draw here CH2 minus single bond CH double bond NH2 plus. What it shows that यहाँ पे पॉजिटिव चार्ज था तो इसमें भी पॉजिटिव चार्ज है, यहाँ पे नेगेटिव चार्ज था तो इसमें भी नेगेटिव चार्ज है, यहाँ पे चार्ज नहीं है तो total net charge would be 0 because this is -1, this is +1 and net charge 0. Now what about this? In case of this, a system starts from this pi electron. So I give it here. I can say that A, B and C, ये और B के बीच में जो है वो B और C के बीच में आ जाएगा और C पे जो चार्ज है वो कहां पे आ जाएगा मित्रों, वो आ जाएगा A पे. सॉरी, okay, this is the resonating structure. So in this way you can draw this resonating structure. We will do the practice for this also. Suppose I have a structure like this. I have a structure like this. So from where I have to start the arrow? I should start from this negative charge because I have told you the first preference negative charge, then lone pair or the plus charge. So it moves, in this case, it moves from this here. So what happened? लिख देते हैं यहाँ पे, this is A, B and C. So among A, B and C, I can say this is double bond O, then this is a negative charge, then this one and Cl. Now this negative charge moves. This is now next is this is A, B and C. To draw the arrow, it come at here. So I can say this is double bond, this is a negative charge comes to the A. Now there are two possibilities. One is this one. So I can say this is one of the structure and another structure is in this way also. So what we get here? in this way, right? This is the possibilities. So in this way you can draw the structure. Let us try to another one also. If I have a structure like this, this is O. No, we will not take this O, we will take this what, carbon. Just I show you only one, the remaining you have to try. Okay, this is carbon plus, this is a carbon minus. So I show you only this arrow here, the pi bond arrow start like this, and here a negative charge, so it will move in this directions. I hope you will try to draw a structure for this also and enjoy the learning. I think I should have to stop at here, and I have to take another